Good morning, students. So, in the last class, we studied about the reactions of aldehydes. Okay, the preparation of aldehydes and some reactions. So, in the today's class, okay, whatever we discussed in the yesterday's class, that is only the preparation of aldehydes. That Rosenman, okay, and ethards, Butterman coach, and also that Stephens. All are the reactions for preparation of aldehydes, and today's class we are going to discuss with the reaction for preparation of ketones. So that is the reaction number 7, that is Friedel-Crafts acylation. Friedel-Crafts acylation. Okay, so what is this Friedel-Crafts acylation? Remember, students, here the reagent is benzene. Okay, so this benzene is going to be treated with acid chloride. That I take RCOCl. So here nothing is there, H is there in all the cases. C6H6. Correct? So this benzene is going to react with this acyl chloride. So this is acyl chloride. This group is called as acyl group, and this one is benzene. So as we mentioned here, Friedel-Crafts means here the reagent used is anhydrous aluminium chloride. Okay, so then what happens? From here, Cl is dissociated. From here, H plus is dissociated. Are you getting? Cl minus and H plus. Then students, now the reagent formed here is, okay, in the place of hydrogen. Here the bond is break here. So this carbon is going to attach here. Okay, so this CO group you may write it as, okay, this is also written as this benzene ring with C double bond O R. So this is ketone. The name of the ketone is alkyl. Maybe okay, just simply you take ketone because we can substitute R still. Understood? So when benzene treated with acyl chloride. Okay, so you may take in the place of acyl chloride, you take acid. If CH3 is there, then only it is acyl. Okay, here benzene reacts with acid chloride in presence of anhydrous aluminium chloride gives ketone. Okay, so students, if you take acyl group by substitution, so I take example. This is example 1. So to this example 1, you take CH3, CO, Cl in the presence of anhydrous aluminium fluid. Here R is replaced by CH. So then so listen, this one is CH3 group, this one is benzene. So how can you name the compound? This one is ethyl, this one is phenyl, this is ketone. Methyl phenyl ketone. Are you may answer right? This one is called as aceto group. Aceto phenol. Because this is a substituent, this is the parental chain. Okay, so here 6 carbon atoms are there, here only 1 carbon atom. This is considered as a parental chain. Acetophenol. Okay, next. So can you write here? Benzene. Okay, reacts with benzene reacts with acetyl chloride. Acetyl chloride in presence of anhydrous aluminium chloride gives what? Acetophenol. This is one. So you may also write that one as a methyl phenyl ketone. So this is one example. Here we are substituting R group by aliphatic compound like CH3. So if we replace this one by phenyl group, means aromatic group, then what happens? That is example 2. Okay, so this benzene is made to react with this type of R group, COCl. Then no doubt here the reagent form is, sorry, not reagent, reactant form is CO. This is the R group. No matter whether it is a aryl compound or aliphatic compound, here in the place of R, this R is going to be substituted. So this one is benzene. Okay, this one is benzoyl chloride. This one is benzophenol. Or you may say diphenyl ketone or benzophenol. Understood? So here, benzene reacts with benzoyl chloride. Benzene reacts with benzoyl chloride in presence of anhydrous aluminium chloride gives benzophenol. Okay, so this is example number 2. So initially we take an example for R is substituted by aliphatic compound. Here it is substituted by this aromatic compound, that is benzene. So this is the general reaction, that is initially what I explained, that is example 1, this is example 2. Okay, this is one of the method of preparation of ketones. So the next one is Clemmensen reduction. The next one is Clemmensen reduction. Okay. So what is this Clemmensen reduction? So students, as I told you, only one type of reaction is there to prepare the ketone. One is from, of course, Friedel-Crafts acylation. Okay. So another one is there by using dialkyl cadmium compounds. That is not that much important. Okay. So I just write the reaction here. Listen. This acyl chlorides are there. Same. Okay, this acyl chlorides they made to react with alkyl cadmium compounds. Alkyl cadmium compounds. Here you take two moles because two R groups are there. Then it is 2RCOR plus CdCl2. Means this Cl is replaced by this R. Not important, but you just remember. Ketones may be prepared from A2 by one is Friedel-Crafts acylation, another one is this. Okay? From dialkyl cadmium compounds. So the next one is the chemical properties of aldehydes and ketones. In that, one is, of course, upon reduction, if aldehydes undergoes reduction, they form primary alcohol. If ketones undergoes reduction means addition of hydrogen, they form secondary alcohol. How? Listen. This is R, C, double bond O, H, to which H2 is added. So in presence of, as I told you, platinum or palladium or lithium aluminium hydride or sodium borohydride, anything you may take. So if platinum and palladium, we should take hydrogen as H2. If this lithium and sodium, we should take hydrogen as in a nascent hydrogen in the form of a square bracket. Next, here hydrogen is added at what? Double bond. So R, C, H. So this double bond is there. One H is added here, another H is added here. If we write, that is RCH2OH, primary alcohol. So this is aldehyde. If you take ketone, RC double bond OR, same H2 is added. The reagents also so and so same. Okay. Here hydrogen is added at the double bond. R C double bond O R is there. This hydrogen double bond is replaced by two hydrogen RCHOH R. So this is secondary alcohol. This is also given in what? The preparation of alcohols from aldehydes and ketones. That we already discussed. So I won't repeat it again. So the important is in this is what? Naval reaction. That is Clemmensen reduction. Okay, listen. Here, if reduction happens, here what is the products formed here? Aldehydes and ketones. When there is reduction, the product formed in presence of the platinum and lithium aluminum hydride and so on is alcohols. But in Clemmensen reduction, the reagent used is zinc amalgam. Okay, zinc amalgam in concentrated HCl. This is Clemmensen reagent. So if we take aldehydes or ketones, both. So I take R, C double bond O, H. Okay. So if hydrogen is added here, if hydrogen is added here, so instead of we are using zinc amalgam in concentrated HCl. So students remember, initially if RC double bond OH is there, if H2 is added, we are going to take R, C, H, sorry, OH, H, CH2. If to this again H2 is added, OH minus is removed from here because we are using concentrated HCl, acid. So H plus is removed from here. R listen. Again we are adding H means H plus is removed from here. So, listen. And write it. This is OH. This is the reagent H2. This one is as H plus and H minus. This one is as OH minus. So OH minus removed from here, H plus removed from here, and this is going to attach. That is what active. Okay? Means that's why I wrote here 2 moles of H. Here we will be using concentrated HCl. So acid, concentrated acid means of course it has more affinity towards water. Then they form R. So here completely oxygen is removed. That is CH2, H plus H2O. Here completely oxygen is removed, H2 is added. So we can simply write it as CH3, H2O. This is what? Alkane. This is in case of aldehyde. Okay, so this is aldehyde, that is reduction, they give alkane. Means the aldehyde treated with zinc amalgam. Zinc amalgam means zinc with mercury in presence of concentrated HCl, in presence of concentrated HCl undergoes. So addition of hydrogen is what? Reduction. And at the same time, from this, oxygen is also removed. Addition of hydrogen and removal of oxygen together called as what? Reduction. Okay? So, here, aldehyde is treated with zinc amalgam in presence of concentrated HCl undergoes reduction to form alkane. This is for what? Aldehyde. Later I will explain ketone. So example here. Okay. Example 1. You will take CH3, C double bond H. That is ethanol. Undergoes reduction in presence of zinc amalgam concentrated here. Okay, the reagent formula is CH3, CH3. Okay, plus H2. So students, this one is ethane. Understood? How do you write? In the place of aldehyde, just to replace ethanol, then treat it with zinc amalgam in presence of concentrated HCl. Okay, zinc. And therefore, reduction to give ethane. Understood? So what you have to remember here students, this as I told you initially, if in the presence of platinum or palladium or any other lithium aluminum hydride or sodium borohydride taken as a reagent or a special species or catalyst, so then the product formed is the R group. But this is a special reaction, Clemmensen specially studied by using these reagents to prepare alkanes. Instead of alcohol, they are giving what? Alkanes, because double reduction takes place. Twice addition of hydrogen takes place. H2, H2. Okay, so 4 hydrogen atoms is going to attach. So this is what? Aldehyde. So in the place of this, you may take benzene also. Understood? In the place of this, you may take benzene. So this is what aldehyde we explained. Now ketone. How this Clemmensen reduction reaction is exhibited by ketones. Reaction with RC double bond or same 4 hydrogen atoms. Right? So in presence of zinc amalgam in concentrated HCl. So students, reduction takes place at this position. Oxygen is removed, hydrogen is added. To remove this oxygen, we require 2 hydrogen, that is H2O. So to balance this, we need to have CH2. So this one is alkane. This is ketone. Okay? So if you want to write the explanation, ketone upon reduction with zinc amalgam in concentrated HCl gives alkane. Okay, I'll write both the examples here. One is aliphatic, another one is aliphatic. So that is example 1. So in the place of this, I take CH3, C double bond O, CH3. Acetone, I will write it as propane to O. Okay, another name is acetone. So undergoes reduction in presence of zinc amalgam and concentrated HCl. Note that the product formed here is CH3, CH2, CH3, that is propane. CH3, CH2, CH3 plus H2O. This is what? Propane. Now statement. This one, ketone means acetone upon process reduction. The reagents are with what? Zinc amalgam in concentrated HCl gives propane. This is example 1. So if you take example 2, a aromatic compound. Acetophenone upon reduction with zinc amalgam in concentrated HCl gives ethyl benzene plus H2. Okay, is high in green. Then, how do you write? Acetophenone, because we have ketone, upon reduction with what? Zinc amalgam in concentrated HCl. Zinc amalgam in concentrated HCl gives ethyl benzene. This is what? The Clemmensen reduction reaction for both aldehydes and ketones. They want our students when ask, write the preparation of alkenes from ketones and name the reaction. Okay, so they make you complete the reaction by this reagent and this is question mark and the product. You need to write the reagent of the Clemmensen reduction based on the what is it? Product. If alkane, then this must be the reagent. If alcohol, platinum or palladium or sodium borohydride or lithium aluminium hydride. Okay, this is how to remember. Reactant, product and the reagent. And also the process, whether it is reduction, oxidation, addition, subtraction. So not subtraction, it is elimination. Okay, it is not subtraction here, it is called as elimination. So this is all about Clemmensen reduction reaction. So the next one is Fischer reaction. Fischer reaction. So what is this Fischer reaction? So listen. Here the reagents used is what? Hydroxide and alcoholic KOH. KOH ethylene glycol. These are the reagents used in the Wolff-Kishner reaction. So students, for aldehydes and for ketones, both the reacted. So listen, I take initially aldehyde. Only one example I will give for this. So if aldehyde is there, aldehyde means R, C, double bond O, H. So I just replace this group position only. So I take this C double bond here, R here, H here, aldehyde. This aldehyde initially treated with hydrazine. Initially treated with hydrazine. Okay? So then the form is a water molecule is going to be removed from here. That is C R H. So H2O is eliminated. I will represent it like this. Next one is double bond. Double bond. Yes. single bond. Okay, so next, further treated with KOH in ethylene glycol. KOH in ethylene glycol. So note down students here. Addition reaction takes place. So this H2 is going to add here R C H2. This is H. C H2S. This N2 is eliminated plus N. Means this completely becomes H2. Means alkane group again. How the reaction will form? This gang triple bond gang is going to remove. The remaining is RCH3. So that we cannot show in the reaction. Just I am explaining it. Understand? So listen. How to write this? This one is. So both Clemmensen reduction reaction as well as Wolff-Kishner reaction both explain the preparation of aldehydes. Sorry, the preparation of alkenes from aldehydes and ketones. But the thing is, in the Clemmensen reduction, zinc amount will be concentrated itself is the reagent. The Wolff-Kishner, this is the reagent. Hydrazine. Okay. So here, aldehyde reacts with hydrazine followed by reaction with KOH ethylene glycol reaction with KOH ethylene glycol gives alkane. This is for what? For aldehyde. Okay, so the next one is example. Okay, so this aldehyde, I will take a simple aldehyde that is CH3, C double bond O H. That is ethanol. So treated with hydrazine. Water is removed. No need to write water is removed. Okay. So C, here R is replaced by CH3 and remaining everything is same. This is imine group. Followed by reaction with KOH in ethylene glycol gives CH3 is methane plus N2. This is the okay. So this is the product formed here. So students, when ethanol is treated with hydrazine, okay, so it loses a water molecule. When it loses a water molecule, then it forms a compound C double bond N in H2, that is imine group. Okay, so followed by this reaction with potassium hydroxide KOH in presence of ethylene glycol, alcoholic KOH, they form ethane. Okay, so here, how do you write? In the place of 48, just replace ethanol. Ethanol reacts with hydrazine followed by reaction with KOH in ethylene glycol gives ethane. This is the reaction. For what? For aldehyde. Understood? So here the few only changes is what? This H is replaced by R, then it is ketone. Understood? Just write the reaction here. Wolff-Kishner reaction for ketone. Okay? So the next one is for ketone. General formula of ketone is RC=O(R). So students here ketone is here. I will just take like this initially. So they are made to react with hydrazine. Say water molecule is removed, then they form R C R double bond single bond NH2. So followed by the reaction with potassium hydroxide in ethylene glycol gives same carbon is here R R H2 is added here, that is N2. This one is what? Alkane. This one is ketone. Okay, how do you write? Ketone reacts with hydrazine followed by reaction with KOH in ethylene glycol gives alkane. So I'll just take the example here. Both R groups are replaced by CH3, C double bond O, CH3, that is acetone. This acetone is treated with hydrazine. That water molecule is removed from here H2, from here oxygen. Then they form this type of adduct. Okay, then followed by reaction with KOH in presence of ethylene glycol gives alkane. Just write CH3, CH2, CH3 plus N2. This is propane. So students, when acetone reacts with hydrazine by the removal of water molecule, they form amine, followed by the reaction KOH in presence of ethylene glycol, alcohol and KOH, they form propane. Okay, so this is what the reaction of aldehydes and ketones explained by the scientist Wolff-Kishner. In the both Clemmensen reaction as well as Wolff-Kishner reaction, from the reaction of aldehydes and ketones, the product formed is alkane. But the thing is, in Clemmensen reaction, the reagent is zinc amalgam concentrated is here. Here, the phenyl hydroxide, not here, simply hydroxide in KOH, KOH and ethylene glycol. Okay, this is what the reagent. The next one is Next one is the distinguished test between aldehyde and ketone. Okay. Distinguish test between aldehyde and ketone. So students, two reactions are there. One is tolerance reagent, another one is Fleming's solution. So Fleming's solution A and B is there. That is copper sulfate, aqueous copper sulfate solution and alcoholic copper sulfate solution. Okay, tolerance reagent is, so it is a ammonium silver nitrate. Ammonium silver nitrate is called as tolerance reagent. And this is copper sulfate solution, both aqueous and alcoholic, that is Fleming's solution. So students, if tolerance reagent is there, then aldehyde is there. Okay, then they form silver PPT, or they form silver mirror. So listen, if any organic compound is there, so that organic compound in a test, we are having tolerance reagent, that is ammonium silver nitrate solution. Then a silver mirror is formed under surface or a wall circular test tube. If this is the test tube, inside the test tube here, any aldehyde or ketone is there. If it is aldehyde, assume when we add ammonium tolerance reagent, ammonium silver nitrate, they form a silver mirror on the wall of the test tube. You can see our face in that. Due to what? Due to the precipitation of silver metal. How the reaction takes place? So listen. Aldehydes are there. They are going to substitute with silver nitrate. 2 times ammonium silver nitrate. Okay. So what they will form, students? They dissociate Ag metal plus, okay, this RCH4 changes to RCOO minus plus NH2. Okay, this is the reagent. So reaction going to happen. Due to the precipitation of Ag, they form silver mirror. Distinguished test. So if ketone is there, it cannot be possible. Ketone cannot reduce this tolerance reagent. Ketone cannot precipitate the silver. Next one is Fleming's solution. If Fleming's solution is there, if aldehyde is there, they form red PPT. If red precipitate is formed after the addition of Fleming's solution, then we came to know this is aldehyde. If there is no red precipitate, then it must be other than aldehyde. If only aldehyde and ketones are there. If silver mirror form, aldehyde. If cannot form, ketone. Sorry. Okay, ketone. If red precipitate is formed, aldehyde. If cannot form, that is ketone. Understand? So here how the reaction happens. This is RCH4 aldehyde is treated with copper sulfate solution. Is copper plus 2 ions are there. Of course, OH minus ions also. Here they form RCOO minus Cu2O. So copper oxide, cuprous oxide they will form. This is what? Red PPT. Okay, here it is H2. So they form red PPT. Then red PPT tells about what? The given compound is aldehyde. So this is only the distinguishes. They'll ask only one more question. What is tolerance reagent? What is Fleming's solution? Important in lab as well as in tables. For 1 month then answer. So this is all about aldehydes and ketones. In the tomorrow's class, okay, some reactions are there. For the reaction, alloform is there. Okay, and also last order, order condensation. That is we will discuss in the next class. Thank you.